in this next example, we're going to be fitting some data to a logistic model. So I'll be going through this video a little bit quicker than the previous one because I'm just going to be assuming you know what to do now, and I'll just step you through the steps. So as we did in the last one, we're just going to double check what kind of model our data fits. So the data that I've got is titration data, and essentially as we add NaOH, which is sodium hydroxide, we have a sensor that measures the requisite pH, and as we add more sodium hydroxide, the pH goes up. So if we generate this plot quickly just to see, same method as last video, it's pretty evident that this data follows a logistic function this time, and we know from our theory that a logistic function has the form, or I'll call it t, or f of x actually, equals L on 1 plus a e to the minus bt. Okay, and in terms of our parameters, if I want to call v our x-axis and perhaps pH even as our y-axis, you can say that pH equals pH equals this constant L on 1 plus a e to the minus b b. Okay, so we get this expression here. I'll extend this out and then get this one to shrink back. Okay, so we got these two set of expressions here, and what we're first up going to do is assign constants in this column. So in our logistic model, we have three constants: L, A, and B, and like we did last time, we're going to just prematurely set these at 1. Okay, and we're going to set up our model equation to start off with, which is our logistic model. So we're going to copy this equation here in Excel notation. So it's going to be L divided by, we want to use brackets, 1 plus A times exp, which is e to the negative b times by our v here. And also remember that we want these constants to lock when we move down, so we are going to add the dollar signs on this one, and this one, and we should be able to drag this down now and get some values. And once again, like last time, if we go select data, we can add this model plot alongside our raw data plot to see how well the model fits. And evidently, just looking at the numbers, it's not going to be great, and as you can see, it's not great. That's fine. So next step is to calculate the error between the model data and the raw data, like that, and we can drag this all down here, and then we get a bunch of errors. We can see this time they were negative, not a problem. Our next cell is our error squared to get rid of all those negatives, easier to deal with. Okay, drag that all down, and just a tip, instead of dragging down, you can also double click on this box in the corner here. That'll do it for you. And then finally, we can use mean square error, or work that out, and that's just an average of all of those errors squared down here. So we can just highlight this and enter, and this gives us our mean square error. Okay, now we can go over to the solver tool that we talked about before, and we can select that, and now we want to set our objective once again to minimize this mean square error, like so, and we are going to be changing 3 parameters this time, and we can do that like so. Now we have no constraints once again, so if we just go ahead and click solve, we can see that we've got a lovely fit to our data, and this orange represents the fitted logistic model. So once again, this will have form pH, if you wanted to plot this in Desmos, equals 13.9 divided by 1 plus 47 e to the minus 0.179 v. And that would be the equation of our logistic model that we gain from this fitting process.